We are back again. We are done with question 1 to question 3. Now let's look at question number 4, 5, and 6 and 7. Now we're looking at functions. Let's make it fun. Let's make it fun. So in functions, we have 3 or 4 functions which you should be able to know by now. We have our first one, which is our straight line function. We have our second one, which is what? Help me, guys. Help me. Then we have our parabola, which has a happy face or a first. Then we also have a hyperbola, which has an asymptote, the vertical as well as the horizontal asymptote. Then we also have, what do we also have? We also have an exponential function, which which is now introduced more specifically in grade 12. Now when we're now looking at what we call the inverse function. Then after that, that's what we need to know, and the strategy is the same. We need to know your x and the y intercept. If it's a hyperbola, know your asymptotes. If it's a parabola, know that we have what we call the turning point, because the function is like so it has a turning point. Where it turns is what we call the turning point. Now question number 4, without wasting much time. Question number 4, the question goes, sketched below is the graph of h of x equal to 1 over x plus p plus q. Then the asymptotes of h intersect at that. So we can see that this is a hyperbola by the way it even looks, that it have another function there. Then we have an asymptote at x is equal to 1. That's a vertical asymptote. At y is equal to 2. That's a horizontal. We already know that. It's who we are. We understand the concept by now, okay? The moment we see this, we are already happy, all right? Now, write down the values of P and Q. No ways. We know that originally our function, let's write 4.1.1. Originally, our function of a hyperbola, it's always, we are given h of x equal to 1 over x plus p plus q. So we can literally look at our function and be able to determine what is the value of p. So we know that this is the vertical asymptote, this is the horizontal asymptote. So therefore our p will just be equal to -1 and our q will just be equal to the value which we have on the horizontal asymptote, which is equal to 2. Now let's look at the next question. We don't have time, guys. We need to work on time. Calculate the coordinates of x-intercept of h. Boring, because by now everyone knows that the x-intercept of the function is always determined by letting y equal to 0. So we now know our h of x is equal to 1 over x minus 1 plus 2. Okay, then after that, what do we want? This is our h, so we want the x-intercept. So we know that we let y to be equal to 0. Then if we let y to be equal to 0, which means 0 is equal to 1 over x minus 1 plus 2. Transpose that. -2 is equal to 1 over x minus 1. Then we have -2 x minus 1 equal to 1. -2 x plus 2 is equal to 1. Then -2 x is equal to -1. Then x is equal to 1 over 2. Then we know we write this as a coordinate, so that will be 1 over 2 is to 0. So if you are not like me, use your calculator as much as you can. So here we can see we cross multiply, then we got -2 multiplied by x minus 1, which is equal to 1 on the other side. Then after that, we solve the question. We broke the question down so that we can be able to have the correct answers. Now we have our x equal to 1 over 2. Then we have our x-intercept there. Great. Now the following question, write down the x-coordinate of the x-intercept of g if g of x is equal to h of x plus 3. What? Boring, guys. We know that g of x is equal to h of x plus 3. So we know originally our h of x is equal to 1 over x minus 1 plus 2. So now we have shifted the function 3 units to the left. So the moment you see x plus something, which means it has been shifted some units to the left. If it's negative, it has been shifted to the right. So this is what we need to know, and this is what is important there. So on 4.1.3, we can be able to get that, because this will just be equal to 1 over x plus 3 minus 1 plus 2. Then that will be 1 over x plus 2. Then what do we want there? They are asking for the x-intercept. So as always, we substitute there. Then we have 0 here, because now we want the x-intercept. We are letting the y to be 0. So 0 is equal to 1 over x plus 2 there. Then we have -2 equal to 1 over x plus 2. Then we have our -2 x plus 2 equal to 1, negative 2x minus 4 is equal to 1, then negative 2x is equal to 5 divided by negative 2 divided by negative 2. Dango equal to 5 over negative 2. That will be our x-intercept again, because we understand that this should be a coordinate. We put that in a coordinate format. Negative 5 over 2 is to 0 will be our x-intercept for the reflected function. 4.1.4, the equation of the axis of symmetry of h is y equal to x plus t. Determine the values of t. What is important is to understand that this is a positive gradient. So when it's positive, which means we're just going to add. So this is going to be our h of x was 1 over x plus minus 1 plus 1. So this is just the summation of this, so that we can get the x of symmetry. So that will be that function. Let's double check that. So we have y, so this will be y equal to x minus 1 plus 1 there. Okay, so that we can be able to get our correct values there. So after that, we can be able to substitute this, then we get our correct answer. Then definitely our t is just equal to 1. Then we are done and we are out there. Next question. Because literally we have y equal to x plus t, then this can be 2 equal to 1 plus t. By just substituting the coordinate we have, then we can literally see that 1 is equal to t. So our t there is just equal to 1. So that's why I was like, this is straightforward and this is easy. Everyone just have to like solve it in that particular way. Now the question of the x, we have solved that. Determine the values of x for which negative 2 is less or equal to 1 over x minus 3. You can solve this, guys, in terms of applying what we call the inequalities. Okay, instead of looking at the function, you can just solve it as well. So on 4.1.5, someone can say negative 2 is less or equal to 1 over x minus 1. But literally we can see that this is h of x. So in other words, they're saying find in a function where h of x is less or equal to negative 2. So if you can't see it, you need to solve it so that you can create the problem, the answer. So this will be 1 over x minus 1 plus 2 greater or equal to 0. Then therefore, looking for the critical values and doing everything, we should get our x to be less or equal to 1 over 2, or our x should be greater than 1. So we just solve this. Then after that, we look at the function we have. Then we have the proper answers. Right. Then 4.2, this is a parabolic function, which is so intense. Okay, so on the parabolic function, we can just play around and solve this parabola, because we are given the graphs of f of x, we could go to that, and we're also given g, which is an exponential function, as sketched below. E and h. Okay, they're on the x-intercept, yes. Then also c is the y-intercept of f. Okay, let's check that. So we know y-intercept, which means x at c is equal to 0. Then we're also seeing that the both graphs, they intersect at point D. Okay, write down the coordinates of c. C is situated in f, and c already we're told that it is the y-intercept of f. So already, we are already cruising. 4.2. Let's change the pen there. Okay, so since c is a y-intercept, which means our x value is always equal to 0. So that one is just easy, because we know that c is 0 is to y. So we just want y. So originally we are given f of x, which is equal to x squared minus 4x minus 5. Let me double check that. Yes, minus 5. So we now substitute f. So in other words, we need f of 0 here. So that will be 0 squared minus 4 times 0 minus 5. Then we have negative 5 there. So then therefore, the coordinates of c will be negative 5 is to, sorry, 0 is to negative 5. Then after that, we are happy from that point. Now, moving forward, sorry guys. Yeah, so we solved it by saying that we know that this is a y-intercept of f, so which means x is equal to 0. So since x is equal to 0, we can determine f of 0 so that we can get the y value of point C. Right. Proceeding to the next question, write down the coordinates of D. D is the turning point of f of x. All right, so we know that calculating we have 4.2.2, so we know that turning point, we calculate x is equal to negative b over 2a. What is our b? Our b is negative 4 divided by 2 times a, negative positive 4 divided by 2. Then we should be able to get our value to be 2 there. Then after that, what do? We calculate the y value. Y is equal to 4ac minus b squared divided by 4a. Okay, that will be 4 times 1 multiplied by c negative 5 minus negative 4 all squared divided by 4 multiplied by 1. Then we should get our value there to be 9. So therefore the turning point is equal to 2 is to negative 9. That's the coordinates of D. So we can literally say that then D will be 2 is to negative 9. So that's just straightforward as it is, guys. You can literally see that. So if you don't want to use this formula, after you have calculated the x value of the turning point, just substitute this x value into the original f of x function. Then you get the y value of the turning point. Now determine the values of a and q. A and q. So first things first, we need to determine the values of a and q. So we can see that q is equal to the c value, the y-intercept of c, because we can see that it's not touching the line or the y-intercept or above the value of c there, which means that c there has what we call the asymptote. So the q value there, it's easy to find. Our q will just be equal to negative 5. That's the first thing which we saw there. Okay, let's write it down first. So there we can literally see this was 4.2.2. So 4.2.3, the q value is just equal to negative 5. Okay, q value is equal to negative 5. Full stop. That's the first thing which we know, and this is the first thing which we are able to analyze for the function. And we are also given our g of x, which is equal to a times to the power x plus q. So now we have q. How can we find a? Now let's see if we now have point d, so we can substitute point d in g of x. So literally we have y equal to, here we go, yes, y equal to, what is a? Our a is what we want, 2 to the power x plus our q is negative 5 there. Then we can substitute d, so that we can have negative 9 equal to a 2 to the power 2 minus 5. Negative 9 plus 5 is equal to 4a, because 2 squared is 4. Then you divide by 4, divide by 4. Negative 9 plus 5, that's 5 minus 9. Negative 4 divided by 4 equal to a. Then our a is equal to negative 1. Then therefore we can see our g of x is equal to negative 2 to the power x minus 5. Easy stuff. We're just solving. We are cruising nice because we're able to see. So what we need to know in function is that be able to calculate or be able to solve this function in a way that you can be able to see and conceptualize your function so that you can get the correct answer. Now write down the range of g. G is an exponential function. You can see that it's starting from negative infinity and it's ending at our asymptote. So we can just say y should be less than negative 5 there. Okay, because we can see that it's starting from negative infinity, but when it comes to its asymptote at y equal to negative 5, it doesn't overlap that, so it's always be below that. So definitely automatically y should be less than negative 5. Or someone can say that y is an element from negative infinity to negative 5. So this and this, they are the same, but people prefer different ways. So one of the two will be marked correct. Determine the values of k, for which the value of f of k minus k will always be positive. So this is easy. So this value or this function will always be positive when, okay, because we just put in k. So when our k is less than negative 9, it's always, because bear in mind that we are looking at f of x, and f of x is what we call the parabolic function. So we are saying at f of k minus 9, which means now we have now shifted the graph negative 9, which means 9 units downwards. So we can literally see that these values for k for which f of x will always be positive, which means the function will always be found on a positive side, because we just have shifted the function 9 units downwards, but still the function is still located on the positive segment of the function. Then after that, we are happy. Then we are done with functions. Let's just go through this one and see if we can browse through it. The graphs of g of x is equal to 2x plus 6, and the g inverse, the inverse of g, okay, are shown in the diagram below. D and B are the x and y intercept. All right, okay, boring, because now we already know that D is the x-intercept and B is also the y-intercept of the function, which means B will be 0 is to y as a coordinate and D will be x is to 0 as a coordinate. And we can literally see that B should be positive y value and D should be negative x value. And we are also told that C is the x-intercept of the inverse function, so that would be our C there. Then our A is just the point of intersection. Write down the y coordinate of B. Yeah, B. So of course we substitute x there to be 0, so that will just be easy, guys, because we just have to multiply by 0 plus 6. Then after that we'll be able to get our function there. So let's show it down. Let's write it down. Question 6. Okay, so B, we already say that B is 0 is to y because the y-intercept, so we substitute B 0 is to y in g of x. So where there's x, we put 0, so y will be 2 times 0 plus 6, then we get 6. So therefore the coordinates of B will be 0 is to 6. This is easy, guys, we don't have to waste time on that. Let's proceed. Determine the coordinate of inverse function. So how can we determine this? So of course we know that g has its own inverse, and we also know the function of g of x. So we are given originally y is equal to 2x plus 6. So the first thing, we swap x and y, then after that we solve for y, then we divide by 2, then after that we have y equal to 1 over 2 x minus 3. This will be our inverse function, g inverse there. So we were able to see that. So we're just solving for the inverse function. That shouldn't take much time, because the first thing we know, we transpose or we exchange x and y, then from that we solve. Determine or calculate the coordinates of A. A is the point of intersection. In other words, where g of x is equal to g inverse of x. Okay, our g of x is 2x plus 6 and our g inverse is 1 over 2x minus 3. Then we can solve that by saying 2x minus 1 over 2x, because now we have transposed that. So that should be equal to negative 3 minus 6. Then 2x minus 1 over 2, which is 3 over 2x, because that's 1,5. Yes. Equal to negative 9 divided by 3 over 2 divided by 3 over 2. Then we can get the x value there to be negative 6. Okay, then from there we can literally see the coordinates of A will be negative 6 is to negative 6, because we can look at the location of the function and we can see that's where the function is, that's where the intersection is. Why is it that this will be at the x? So we sub this x value in one of the equations, so that can be 2 times negative 6 plus 6, that will be negative 12 plus 6, which is giving us this negative 6. So we got the x value, then from that we substitute the x value in either g of x or g inverse of x. Now proceeding forward, calculate the length of AB. A and B. This is easy. We know the coordinates of A, we know the coordinates of B, so we can just use our distance formula as always. Then we'll be able to calculate the distance. So we know that the distance of AB is always equal to x2 minus x1 squared plus y2 minus y1 squared. Then after that we put that, so we should just apply what is our A, what is our B, we substitute the values there. So AB, where is A? And B is 0 is to 6, so that should be just 0 minus 6, that should just be 0 minus 6 squared plus y2, which is 6 minus, what is B, negative 6 there, negative 6 squared. So this will be square root of 6 squared plus 12 squared, then using your calculator, that would be root of 180, because 6 squared is 36, 12 squared is 144, 144 plus 36, that's 180. Then you can leave it like this. I mean, it's only 3 marks, you don't have to, but like if you want, this is approximately 3.42 units. Okay, right, now calculate the area of triangle ABC. Triangle ABC, this is easy. You just calculate the sides of AB, you also calculate the sides of BC. Now we know the length of AB, we can just calculate the length of AC and also the length of BC. Then after that we use our area rule, then we should be able to get the correct answer on that problem. Moving forward to the last section of the day, which I want us to cover. Now let me just perhaps stop here on functions. Then next time we'll look into the calculus and probability. Till we meet again, have a great evening, have a great day.